All right. I remember from the beginning, green button is what changes the slides. So, whoa, the lights are bright. Thanks to Colleen for that presentation, starting the regulated transmission utility portion of today's event. So yeah, I'm Nick Baldenko. I'm from Eversource Energy. I'll jump right in. Eversource is New England's largest energy delivery company. We have electric and gas. Full disclosure, I have no idea what goes on the gas side. I'm an electric guy. So we operate in Connecticut, Massachusetts, New Hampshire. About 4.5 million customers across those 3 states. And I raised my hand on all those questions before from Colleen about transmission, distribution, and generation. I used to work in distribution in Connecticut, but I've been working in transmission for the past decade or so. And I worked in generation for 1 year at a different company. So not all in the same region. We're a restructured market, so we don't own any generation. This is from corporate communications about our clean energy strategy, which is obviously what we're here talking about today. So Eversource has a lot of, like many other utilities, commitments to clean energy transition. I think ultimately what my presentation is about today is, you hear from the ISOs about planning, I think a lot of times from a much bigger picture, holistic perspective of how do we evaluate these things and design market products and make sure we have resource adequacy, all those things. Eversource is, the transmission owners and the distribution companies are sort of a little bit more on the implementation side of, well, we just have to build things to make it work, from the grid perspective. So obviously in a restructured market, we don't own any of the generation, and yet our name is on the bill when you pay for your power, so we kind of have to make sure there is enough generation, so we're in an interesting spot there. So I'll start off talking about the planning processes in ISO New England. So I guess I would say traditionally, we have these single value transmission planning processes. And since the advent of the restructured markets and the ISOs, this is how it's been in New England. That we kind of separate the idea of reliability, economics, and public policy. So in reliability, that's pretty much everything that we've built for the most part in New England. We have these annual cycles. We're studied on a 10-year horizon. You do the load flow in PSSC. You do stability in PSC, or load flow in PSC and Terra, and then stability in PSSC, and you do a short circuit and all these technical things, and you find needs and you solve them. If they're short term, ever since Order 1000, if they're short term, they're carved out for the incumbents. If they're long term, they become competitive. We've had one competitive reliability solicitation in New England, which was the retirement of the Mystic units in Boston, led to a competitive transmission solicitation. But other than that, it's all been a lot of just straightforward standard reliability planning. The economic process in New England, up until recently, had been an ad hoc process where stakeholders request analysis, and sometimes maybe you find some issues, maybe not. It wasn't fully standardized, and it was mostly just informational. And revisions are underway right now, and actually Ben Wilson and Richard Koninsky from ISO New England are here today, and they're kind of leading this actual work at ISO New England to revise the economic planning process and integrate PLEXOS into all the analysis and make it align more with the reliability planning from a process perspective. There's cycles, you initiate a cycle, you have a standard set of assumptions and cases, and so that's what's happening on the economic side. And from a public policy perspective, we have this 3-year cycle where the states can initiate a public policy request for needs, and it really has never been used in New England. Like many of the other regions, New England has, most of the states have really aggressive clean energy policy targets and mandates, and yet the policy planning process has never been used. And that's largely because of things like cost allocation and project controls and who has responsibility for what. So that's where we have been. So what's changing in New England? So like I said, both the economic planning process and the long-term planning process. So shout out to Colleen's LTP soup. We have LTTP in New England. But on the economic side, like I just said, this is becoming a revised standardized cycle every 18 months, I think. And actually Ben and Richard could correct me on that. I'm not sure the exact timing. But the first cycle was just initiated after a very long sort of pilot study that ISO New England is wrapping up right now after dozens and dozens of stakeholder scenario requests at the end of it. And ISO is sort of standardizing this into, again, to be similar to transmission reliability planning and having technical guides. And it's all about PLEXOS, saying, hey, our models are in PLEXOS. Here's what our ST settings are like, and this is what our load forecasts are, and here's the data that's public and non-public, and all these different, and here's what your settings should be. On the long-term transmission planning side, this is I guess, an entirely new process. So it's getting at a lot of the same things of the other processes in terms of questions that we're trying to answer, problems that we're trying to solve, but formalizing them into a new process that's specifically about how do we plan. In New England, the idea is 2050 with other milestones in between, but ultimately to 2050, given all of the state policies, right, so it's kind of a policy-based study, but we're gonna go really far out, and we're gonna do some power flow. So we're kind of like thinking about reliability because there are gonna be thermal overloads and things like that. So it's mixing and matching things together to say, how do we really get there, right? Now, there's been a lot of those investigative studies, but what's different now is that ISO New England is formalizing this into a process by which there could actually potentially be RFPs for competitive solutions to solve these problems, right? And I don't know if this has kind of been said informally, and I'm of this opinion, and this is what I'm talking about today, that this is starting to represent what I consider to be sort of a multi-value planning structure in New England. Because you're talking about reliability needs that are driven by policy assumptions and that may be evaluated. Maybe evaluated was put in by someone else. I think they will be evaluated on economic performance in PLEXOS. It depends on how you interpret the tariff and things that are under revision right now, pending approval, FERC, and all those things. But ultimately, that's what's happening here. You're mixing all these different value streams together. And in fact, there's another layer to this, which is we have a lot of asset condition projects, which no one's really talked about a lot today. But while we're talking about all this growth, you also have some assets that are hundreds of, there's literally there's a line between New York and Connecticut that we recently started rebuilding, a 69 kV line, that my boss, jokingly many years ago, was like, oh, you know that Thomas Edison was in charge of the company still when they built that line. I was like, oh, ha, 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 it's so old. And I looked up and was, no, he was still alive. He was literally alive and had ownership over Edison, whatever it was called at the time, when this line between Connecticut and New York was built, and we just replaced it. So really old assets, and that's being integrated into this as well. It's saying, hey, if you have asset condition problems and they overlap with the needs that are found in these long-term plans, let's coordinate all that stuff. So all these different value streams together. Okay, so that's great, that's process, that's ISO stuff. But like I said, we're a regulated TO. We live in a slightly different world, and there's things that need to happen that might not fit into any of these processes, or the processes aren't formalized yet. And so what we're doing at Eversource, one of the things we're doing is trying to, quote, fill the gaps here in these processes with sort of just ideas of how we could do things. And one of those things is pre-building offshore wind interconnection points on the onshore grid, honestly, without really a set process. I mean, we're basically just proposing we want to pre-build this. It doesn't fit. It's not a reliability asset. It's not really an interconnection need yet because there is no generator that's yet interconnecting there. It's just a new idea. Let's get ready for something, right? It's kind of like Colleen was saying, the reactive versus the proactive approach, and this is just an idea of let's be more proactive, right? So this particular project that we just proposed, the application went in 2 Thursdays ago, to the DOE from the New England states, Eversource in conjunction with some other TOs and the New England states for infrastructure law grant money for this project. It's a lot of time we talk about innovation and stuff, but in a lot of aspects, this is a pretty straightforward project. It's a new 345 kV switching station in Montville, Connecticut. We own the property. It's at the intersection of a lot of 345 kV lines. Some of the lines are coming out of Millstone, which is a nuclear power plant we have in Connecticut. There's in Montville, Connecticut, there's a Montville plant, and an old fossil plant that is also in Montville. Those lines all interconnect at a nice property that we own. We said, that's a perfect place to build a substation. It's a couple miles from an inlet from the sound, and You can see the offshore wind lease areas. They can go right up into the bay from the sound and get over there to that substation. So let's just build it, right? Now, okay, how do we use PLEXOS? So when we propose a project like this, obviously since it doesn't fit into any particular planning process and we're trying to get DOE money for it, we kind of need to make the case of why it's valuable, right? So that's where PLEXOS comes into play in this particular case, where we said, we're gonna run production cost modeling in PLEXOS in the ST to basically evaluate some key metrics for this Huntsbrook offshore wind hub. So talking about the analysis itself, right, it's a lot of the stuff you're hearing today is pretty straightforward. We licensed the Energy Exemplar EIC dataset. We had a lab yesterday talking about this. I get a lot of flack for this, but we carve out ISO New England. A lot of people, especially at Energy Exemplar, don't trust carve-outs, but this is what we're doing to get a nodal model. And we create simplified models for our neighboring regions of New York and Hydro-Quebec and New Brunswick. We had to do a bit of cleaning up of the model. You know, New England is sort of at the end of, a little bit at the end of the system where we're pretty small, so sometimes the data gets a little bit blurry there. So we had some issues with, you know, allocations of nodes to different regions that were incorrect in New England, and some interface definitions and all those things. And what's, I think, really positive is we've had a very good back and forth with the data team at Energy Exemplar, and those corrections are actually in the new revision of the EIC data set. So anyone who does license the data set will, you know, be able to benefit from the fact that you won't have sort of false congestion at the nodal 115 kV level in New England, based at least largely on the node region membership. So that's been good. Like I said, our analysis is 115 kV nodal, all lines in. We're not yet doing contingency analysis for this stuff. We benchmarked this all to historical data, and ultimately we're running the project for 10 years, hourly, nodal production cost, is starting in service in 2031. The inputs, standard stuff. We take the fuel prices and all the generator properties from Energy Exemplar. We trust you. You know, we do a little bit of validation, but you know, that's good for our purposes. Load forecast from ISO New England, wind and solar profiles from ISO New England, and the way it's working within Eversource now, which is a constantly evolving thing, is that we're working with system planning, so transmission planning, which are separate. These are separate groups now at Eversource, because as a TO, we've never really had to have economic planning in the past 20 years since we divested all of our generation assets. So basically, system planning says, hey, this is what the project looks like electrically. They just give it to us, and we say, oh, we'll model it and see what it looks like, right? And the key outputs we're looking for is emissions, right? That's the key thing everybody cares about, particularly when we're talking about clean energy, and also cost to load, right? And we can go into all the terminology, but when we're talking about this, the property of cost to load in PLEXOS, in the production cost model, we, you know, effectively is depending on your settings, the calculation of the LMP times the load, which is, you could argue, the wholesale energy cost to load, but we kind of call it the proxy to load serving entity expense, even though there's other things out there. There's capacity ancillaries. So it's, a lot of this is still trying out new things, but we're at least getting a proxy for potential cost benefits to customers. And then a very long list of things that are not in the scope of the analysis, right? This is, I think, like a lot of people here, we're fairly new to PLEXOS, so we try to start at the beginning and then ramp things up. So we're very careful to say, hey, we're not doing capacity expansion, we're not doing contingency analysis, we're not looking at long duration storage. We do have some pumped hydro in New England, so that's already there. So you could, you know, to an extent, that's long duration storage, but nothing new. Out of market offshore wind contracts, that's a big thing. If you look at, you know, read the news, some of these offshore wind contracts are pretty pricey, but we're not considering that impact in this analysis. We're just looking at the wholesale energy market. And like I said, other markets we're not really looking at. So here's some high-level results, right? It's not too surprising that if you inject a lot of offshore wind into a fairly uncongested node, your emissions will go down and your cost to load will go down, right? It's pretty straightforward. I think the biggest value that PLEXOS provides to us in an example like this, where we're writing a grant to the DOE for money for this, is to quantify potential benefits. You know, the ISOs are talking about pathways, scenarios, and we do that as well for intelligence of other things. But in this case, we're evaluating a project, right? And the idea is, what's the potential indicative value of this project under a reasonable set of assumptions. And in fact, we did run 5 or 6 different scenarios, and this is an example scenario. But from a perspective of trying to, for certain stakeholders, policy stakeholders, to say let's give a number that you can use as a point to say, yes, this has value, so therefore we'll agree to revise a process or integrate this into a new type of plan. So this analysis sort of indicated that injecting 2,400 megawatts of wind, which is the capacity we would size Huntsbrook for, could result in approximately $500 million in annual reduction of wholesale energy market costs, and that's in 2023 real dollars, and a little over 3.5 million short tons of CO2 emission reduction, which is pretty significant portion of the emissions and native emissions in New England. So, I think a lot of this is about process and trying to revise things. PLEXOS as a tool in this case is very much about educating the potential value of a specific project. So doing this, I think, had a lot of lessons for what I consider to be an evolution towards multi-value planning in New England. So on the project itself, like I said, there's significant economic and environmental benefits from pre-building offshore wind POIs. So that's, I think, an important takeaway in general, that if we're proactive on building out onshore infrastructure, it can have benefits, widespread benefits. There are both emissions and cost benefits across New England. And I think from this is a little bit on the just sales pitch side of PLEXOS, it was extremely helpful for Eversource as an organization to be able to meet all these DOE grant application requirements without external consultants, particularly given that these are potentially very sensitive projects if we're moving toward a world these are formally competitive, right? So we get a lot of, we have to be very careful with a lot of things here when there's designs and ideas that could potentially be open up to competitive RFPs. So the fact that we can evaluate these things in-house is really, really valuable to the organization. Then there's the modeling lessons, right? We had to do a lot of cleanup of the AIC data set for New England. And like I said, Energy Exemplar was great. They helped us work on figuring out what the problems are, how to correct them, and then integrated them into the new releases. So I think that's just a lesson on, someone said it earlier today, you can't just sort of have a data set and then it's done. These things are kind of living beings, especially with the load growth, the queues, changes in projects. You have to always kind of be constantly updating. So I think there's a very good back and forth with the Exemplar data team on that type of stuff. Another fun lesson we learned in this that I've talked to a few people about here this week is that voltage, node voltage in PLEXOS is sort of notional is the best term I've heard. It's at worst you might say meaningless, but it's something that you can use as an indicator or a threshold. Since we're not doing AC power flow. I come from maybe like Colleen and some others from the world of transmission planning, where I spent many years. I was an electrical engineer. I spent a lot of years doing AC power flow, and voltage is extremely important in AC power flow, and in reality, it's very important. But when you're running nodal production cost modeling with DC power flow, it doesn't really matter. So it's an interesting thing that you can find these weird techniques in PLEXOS where you can say, what we did in this project is we said, hey, we don't really particularly care about nodal constraints too far away from the injection point of this offshore wind. And in fact, we don't want to get bogged down by those, because if we're studying far out, we know that there's going to be issues in Northwest Vermont, and there's Maine, New Hampshire issues, and there's Boston import issues. There's all these different issues going on. We don't really want to get, we know that the 2,400 megawatts isn't going to have a huge impact on those. What we care about is what's happening in central Connecticut and Rhode Island, southeast Massachusetts. So you can actually just create a scenario where you set the node voltage to whatever you want that's below your threshold. Let's say 0. It's like, okay, let me find every node outside of the regions I care about, set their voltage to 0, and then when I go into my transmission settings and set the line limit, enforcing line limits at 69 kV, 115 kV, 230 kV, all those will be ignored because they have that low voltage. So that was kind of fun. And another thing we found is, interface limit penalties and line limit penalties, variable operation and maintenance costs. These sort of properties and settings can have dramatic impacts on results, which I think is important when we go back to things like talking about ISO New England publishing an economic planning transmission, economic planning technical guide. There's a lot of stuff in there let's make sure we're all using the same interface limit penalty. Let's make sure we're using the same variable operation and maintenance assumptions for different resources, because we know that the results are so sensitive to those things that if we're designing projects to solve the economic, either market efficiency problems or multi-value long-term reliability issues that will be evaluated on economics, we want to design those in a way that they're going to be evaluated in a competitive environment, that we're all using the same numbers. So I think that was a really good lesson for us. And what does this all mean for preparing for multi-value planning? Like, it comes back to the same stuff I've been saying. ISO's revised their processes with both economic planning and long-term planning. They're going to be using PLEXOS, right? They're going to be using similar models. ISO's developing their own model. We're using the Energy Exemplar model. They're publishing some of their settings and data sources. Some of it's not, sensitive. ISO has sensitive data that can't be public, so we have to fill in the gaps. And the idea that we just have these potential market efficiency projects to be coordinated with reliability planning, asset condition planning, and interconnection needs. It's almost like every single study we do hits on all of these things somehow. We analyze an interconnection project. Somebody says, oh yeah, we're rebuilding that anyway for asset condition. And you look at some public policy thing, you say, oh yeah, well actually that's a reliability need. We have a project on Cape Cod recently that's actually under construction. Some of it's already in service, where we had an issue where we needed to serve more demand out on Cape Cod. So there was a reliability need for building a new 115 kV line out to Cape Cod. At the same time, there was an offshore wind project that wanted to interconnect at the end of Cape Cod. Now, in a magical world, those would cancel each other out, but you've seen all the ELCC presentations and whatnot. They don't cancel each other out. In fact, it increased the need. So instead of a 115 kV line, there was a need for a 345 kV line on the Cape. What do? We have this idea of a co-optimized solution. Again, moving towards multi-value planning, where we said, okay, part of the need is reliability, part of the need is interconnection. We're going to design the solution for both and allocate the costs to different stakeholders, either reliability ratepayers or interconnection customers in some way. So you kind of see this co-optimized multi-value approach happening everywhere, and this is maybe just one example. Oh, there we go, that's it. Questions? Happy to. Man, it's hard. Hi. Oh, good, is that Colleen? That's for...
Can you hear me now? Yes. Yes, it is me. Sorry. This is amazing. Obviously, you can imagine I'm like hooting and hollering over here. I do wonder, though, with your transmission background and post the PLEXOS output for the point of interconnection for the offshore wind, did you then go back in PSSE or Terra and run power flow with the substation in and the offshore cables? And kind of did you like forecast or see what would happen in terms of voltage or thermal violations, or?
Yeah, no, great point. So maybe I misrepresented that, which was that transmission planning had already fully designed an electrical solution.
Right?
Okay,
and that's how you were proving the cost benefit and the emissions output from, okay.
And
so,
and just to say that that's sort of step one, because transmission planning is very well established and having for decades of PSSE, same models, same processes, everybody gets it. Whereas this is very new for a TO, so we can't come and say, hey, we designed a project for you. Tell us if if there's thermal overloads and voltage violations, Instead, we just say, hey, we understand you have a cool project, but in order to advance it from, a financing perspective, at rate allocation, policy, stakeholders, siting approval, all these things, we need to be able to talk about more of the benefits and quantify more of the benefits. So it's a sort of a one-way flow right now of design or information from transmission planning to economic analysis, but we very much are interested in and trying and working on having more of an especially when we get into a true competitive environment where it's like, well, that's great that you have an electrical solution, but And in fact, we've had some of those where they kind of just throw projects at us and say, what about this one? What about that one? I say, this is a great reliability solution, but in fact, it actually makes congestion worse because when you're redispatching in Terra to solve overloads, you don't care about how much that redispatch costs. But in PLEXOS, I can tell you that that redispatch is actually quite expensive, and it's happening all the time.
Do you, when talking about dispatch, that's a huge thing, right? Like in the dispatch that you run in your power flow case versus the dispatch that you're seeing in PLEXOS. Do you guys take the time to align those two? Like, do you look at what the planners did and try to match it up when you're doing your data sets and outputting all your things? I know you talked about like the variable O&M being the same, and yeah, that's a big undertaking. So how long did this process take you to?
So
I'll stop.
the first part of your question, which is aligning all of these power flow and production cost assumptions, the answer is we want to do all that. How far along it is, it's early in the process, right? So there's a lot of ideas and initiated projects and things that are in process to both from a technology standpoint of automating and integrating the tools, but also just a process standpoint from who's responsible for what, who's responsible for planning, who's responsible, you know, and so yeah, it's like I'm kind of like, do you want a job? You want to move to New England? It's very complicated, but yeah, aligning all that stuff, dispatches. You even use it. We've talked about the direction of saying, well, how does transmission planning know that their dispatches are the worst case? You know, if they're deterministic worst case scenarios, but I run PLEXOS and actually I've seen worse. You know, so why shouldn't I feed those dispatches to planning and they should run the power flows on those, right? So that's all stuff for the future.